So, good morning, class. Begin a short while. Kumpletuhin na natin muna yung mga classmates nyo. Teka, nasa yung call ko dito. So, for today, essentially, dadaanan natin yung selected problem sets na may solutions. Okay? Nagbigay na ako ng announcement kung ano yung format dun sa Canva page nyo. If you have any further questions, feel free to email me lang and or have your questions coursed through sa class representative nyo. And they can chat me up sa Google Chat lang naman. Okay? Thumbs up pag na-receive yung instructions na yan. Alright, thanks, Simon. Alright, so... Sige. By raising your hand, how many of you pinag-practicean yung mga problems na to in advance? Alright. That's good. Sige. Hindi naman siya formal question, Angelo, no? Since ikaw yung una nagtaas.
Yes. Ano pa siya?
May question?
Low pa.
Okay, kasi I'm gonna lower na yung hands mo. Dito. How do I lower this dito? Sige, just lower yung hands mo na lang dito. Okay, sige, on with the presentation muna, no? I've selected I selected five easy problems na naman rin, but the rest are relatively easy rin naman eh. Kasi with fluid properties, we're just talking about basically mostly algebraic equations lang naman eh. Wait lang, I'm almost forgot. Nagre-record ba ako? Ayan. So, I'm not gonna be recording sa Google tawag dito, Google Meets kasi I noticed there's a drop ng quality pagdating kasi nakadepende ako sa internet ko eh, no? So, I am recording from my desktop and gamit ko yung OBS. I-upload ko na lang nabigay ko na lang yung link later, okay? Para malinis ko pa siya. Alright, on with the show. So, some few reminders lang, no, when it comes to problem solving, no? So, hindi ko na to inulit last time kasi you guys are third year na. Pero it's best siguro na meron tayong reminder on, a way to solve um, problems or analysis siguro sawang-sawa na kayo pero daanan pa rin natin. First things first, of course, kailangan natin basahin yung problem. Sometimes dyan tayo nagkakamali. We thought dinasa natin yung entire problem pero hindi natin binasa talaga ng todo. So, read them really carefully, okay? Tapos, if necessary, actually, it's kind of necessary, you write and tabulate the problem data. Kung kailangan ng diagrams, go for it to visualize. If you need more time siguro, maybe if you have more time pa, you can draw the actual figure para ma-imagine mo yung itsura niya in 3D space and then you reflect yung forces involved doon. Ano ba yung mga involved? And then from there, balik ka ulit sa question, ano ba yung ask? Ano ba yung required? And then from here, okay, so kung ito yung required, nahanap niya is yung density. Tapos given ka lang ng ganitong, alam mo yung density is mass over volume. So, tignan mo kung nandun sa given mo. May cool. Pag wala either of the two, it seems pwede mong hanapin yun based on the provided given. Diba? So, and of course, right dimensionally, homogeneous equations o kailangan like terms. Okay, para ka na nagsusulat yan ng English sentences, kailangan proper grammar. So in this case, kailangan mag-cancel yung mga units para matira yung unit na yung as na hinahanap mo. Okay? Ngayon, yung fourth bullet naman, solve the necessary equations and write the answer with no more than 3 to 4 significant figures. I'm not exactly strict naman doon, but I am strict when it comes to yung rounding off nyo, no? I normally do what I do. I don't usually round off sa gitna ng equation, sa gitna ng solving. I just round off at the end. Gets? So, I usually maintain four decimal places, 3 to 4 decimal places during solving. And then at the end, so meron akong final answer with 4 decimal places. And then i-round off ko na lang into two decimal places lang. Okay? Pero for example, we're dealing with stresses dito, no? Pag English, okay lang naman na parang meron kayong 4 significant here or 5 significant, parang 10,000 pound forces. It's not, sometimes we're talking about uh, pressure eh. Pero we're talking about pascals naman, so Newton meter. Madalas, pag umabot na yan ng 10,000 Newton meter, 10,000 pascals, mas magandang gamitin nyo na yung kilopascal, and then if mas dumami pa yung zeros, sometimes mas magandang gamitin yung megapascal, whichever is appropriate naman. Okay? So, just to write it up lang ng konti, wait lang ah. So, essentially, pag na ako, oh wait, i-modify ko lang kung nasan yung pen tablet ko, kasi pen tablet, okay, oops, screen, and then yung monitor too. There we go. Save. So, just to give an example lang naman, so for here, ano, for example, like I said kanina, kung may 10,000 Newton meter, basically Pascal yan, di ba? Mas magandang tignan siya. Pwede mo isulat na, kung yan yung final answer mo, sulat mo dito yung 10.0 kilonewton meter or essentially kilopascal. Okay? Yun lang naman yun. And then, paste natin to. Okay. So, diretso na tayo. Let's dive right in kaagad pagdating sa answers natin. Oh, yeah. One last thing reminder. So, make sure to review yung answer nyo if it makes sense eh. Back from your static days, sometimes makakuha kayo ng angles and then hinahanap nyo yung direction from the positive x-axis eh. So, measured counterclockwise eh. Sometimes makakuha kayo ng angle na from the other quadrant. Nakalimutan nyo na, kailangan pala i-measure ito from the positive x-axis. So, magdadagdag pa kayo ng 180 degrees. Eh, no? In this case, ganoon rin naman. Eh, no? Does it make sense by yung signs? Does it make sense by yung direction? So, just review lang yung final answer before boxing it up. Okay? Sige. Alright, let's dive right in. So, ito yung viscosity problem natin before. I understand I made a very long derivation doon. Well, an interpretation of the derivation doon. Pero, for our intensive purposes, gagamitin natin yung formula case angle doon. And then, I'll just show it lang kung paano siya gawin ulit. Okay? So, we have here yung viscosity of a fluid is to be measured by a viscometer constructed of two 40-centimeter long concentric cylinders. Figure 2-30 siya. Yan, ito yan. The outer diameter is 12 and the gap between the two cylinders is 0.15. So, 12, itong outer diameter, and then may 0.15 tayo dito na L. Then yung inner cylinder is rotated at 300 revolutions per minute. Take note na revolutions per minute. So, hindi pa siya angular velocity. You have to multiply this by 1/60, di ba? And then the torque is measured to be 1.8 Newton meter. Determine the viscosity of the fluid. Okay. So, recall na meron tayong, pag gagamitin natin yung viscometer, pag ganito yung problem, we have yung formula na ganito. We have yung mt divided by 2 pi ri squared times yung h and then yung wro. Yung angular velocity on outer diameter. Where yung angular velocity is simply 2 pi n. Okay? So, ito, as you imagine, ito rin yung, okay, so ito yung napakita ko na before, ano? So, yung U, essentially is W times RI lang naman ang ginamit niya dito since ito yung rotating body lang naman eh. So, yun yung gumagalaw dito. Sa books, may kita niya may label usually ng 1 and 2. And for the equation ng du over dt, so yun yung equation natin dito, usually is 1 minus 2 lagi, 1 minus 2. In this case, given na yung Ri minus R2, which is yung difference lang naman dito, yung L. Okay? Kung makikita nyo dito, if you recall, this is yung 0.2. Ito yung no slip condition. So, yung velocity niya dito is 0. And dito, meron siyang velocity. So, hence, magkakaroon tayo from the outer diameter. So, velocity minus yung inner diameter niya dito. Okay? Ay, so, wait, baliktad pala. So, ito yung inner, moving velocity minus yung non-rotating body. Then you just substitute yung values lang dun, and makukuha mo yung final answer as 0.158 Newton second meter squared. Okay? Anyway, so ito yung yeah, 0.06, there we go, cube. Yeah. Ito yung ito yung from the last time So for yung actual problem sets natin, we will be dealing with a lot more easier viscosity problem kasi I'll show you how. And then binigay ko sa yung mga problems, yung mga naka-box for you to guys to answer. So take home yun na lang yan. Nagbigay na ako ng instructions. Hopefully nabasa niyo yung sa Canva. Let me know if you have questions doon. Binigay ko na rin yung final answer para at least meron kayong confidence to practice around this. Pero I'm gonna be thinking if I'm just gonna keep giving yung final answer until mag-finals tayo, bago tayo mag-finals. Maybe I'll give a problem set na walang final answer para to test lang yung confidence nyo. Anyway, so we'll be answering dito yung 1-1, 1-7, 1.10, and then 2.14 sa page na to. I got 2 more pages, so pakita ko lang. So meron pa tayong, ito, sasample ko lang ng, ito yung sample problem dun sa Hibbeler, kung paano niya sinolve yung, okay, paano ba mag-solve with this particular equation, Makita mo dito, you're given an equation lang dito, tapos may konting derivation lang. So, konting differential, may konting calculus na ng konti dito. And then, meron rin tayong, nagbigay ako ng sample rin about yung glass tube. Tapos, kung mapapansin nyo dito, nagbigay ako ng, so sasagutan nyo to, 2103, 2105E. So, essentially, binigyan ko kayo ng dalawang klaseng capillary or surface tension problem. So, capillary rise or drop yan. And then, another example ng viscosity problem. So what if there's 2 moving plates naman daw? Okay? And then finally, last 2 examples ko would be this. Okay? So this one, this should be easy kasi parang meron tayong reminder ng static phase natin. And then ito naman, another sample ng viscometer which is a lot easier than the one I provided, to be honest with you. Okay? So let's get back muna dun sa unang problems natin dito. Okay. So, ay, wait a minute. Parang may mali 1.4. Yeah, wait lang. Gas mixture, yung sasagutan nyo. Wait lang guys, wait lang. Baka kasi nabigay ko yung hindi nyo sasagutan and wait, okay, so tama pala. Okay, good. So, akala ko nagkamali ako dun. So, let's go with this 1-1. Evaluate each of the following to 3 significant figures and express each of answer in their equivalent SI units using an appropriate prefix. Not sure kung tinuro to not sure kung dinaanan nyo to before nung statics nyo. Pero I think it's important, parang warm up lang, kada prefix meron siyang equivalent number of zeros yan, di ba? For example, micro is 10 to the negative 6, milli is 10 to the negative third, mega was 10 to the 6. So all we have to do, how do we approach yung problem lang naman ito? Maganda dito, we're being asked to convert it to its appropriate SI units. And with SI, one of the rules ng SI is that ayaw niya na may prefix sa denominator. Kailangan base units lang. With the exception ng kilogram. Okay, so ano yung mga problems na yan? So far wala actually. Okay? Actually, meron pala to. So for A, we have milliseconds dito. We have megaseconds. Ito, with milligrams rin. And then ito naman with megagrams. So, ang goal natin is, kailangan i-convert natin to at least base unit yung denominator. And then the rest, we apply yung appropriate prefix lang naman doon. Alright? So far, so good. So, wait lang. Let's go back dito. So, let's go one by one lang naman. So, the goal is to derive SI forms. Okay? So, let's start with 749. So, nakalagay dito, micrometer divided by 63 milliseconds. All you have to do lang naman is express mo na sila in their respective exponent form. Scientific notation, kumbaga. So, ang base unit nito is meter. Micro is 10 to the negative 6. And then ito, milliseconds. Seconds yung base unit nito. And then yung milli is 10 to the negative third. So, if you recall pa yung rules of exponents, you just apply it. And you would get 11.889 10 to the negative third milliseconds, or essentially this is just 11.9 millimeter seconds. Okay? Pag lumabas sa exam to, is very specific naman. So 11.889, pero sabi sa akin is kailangan convert to into 3 significant figures. So kailangan 11.9 to, and then ilagay ko yung appropriate prefix. So 11.9 millimeter second. Okay? Wait lang I don't see yung questions dito. Okay, good. So, continue lang. Okay. So, sa second one, ganun rin. So, we have 34 millimeter multiplied by 0.0763 megaseconds divided by 263 milligrams. So, medyo masakit tignan siya pag nakita natin yung operation. So, we have to simplify it lang further. Again, we do it by just converting it, again, to its appropriate prefix. So, yung scientific notation niya, yung milli magiging 10 to the negative third, yung mega magiging 10 to the 6, and then, of course, ito magiging gram. So, like I said, kilogram is technically gram technically yung base unit, pero kilogram is an accepted base unit kasi yun usually ginagamit natin. Okay? So, kaya kinonvert ko na lang sa kilogram yan. So, in this case, if makakita kayo ng gram, convert nyo na lang to gram sa denominator, convert nyo na lang to kilogram para mas magandang tignan. Okay? There we go. So, magiging 9.863. Dapat tinanggal ko yung 3. My bad. So, magiging 9.86 megameter tapos second per kilogram. Okay? Ganun rin with letter C, 4.78 times millimeter times 263 megagrams. You just convert them. Then, of course, exponents to. So, technically, mag-add up lang yan into 1.257. So, 1.26 dapat. Okay? So, 1.26 megagram meter. Question sa first problem. Dali lang, di ba? Okay. Sige. All right. Maybe it's not exactly fluid. It's not exactly fluid mechanics related, pero just think of it parang warm up lang siya. Just remembering yung exponents mo, yung rules ng exponents, and then yung division, and then yung algebra. Next naman, okay, finally. So, much more fluid mechanics related naman. Okay? So, we have here an 8-meter diameter spherical balloon, and it's filled with helium that is at a temperature of 28 degrees and an absolute pressure of 106 kilopascal. So, take note, we have absolute pressure of 106 kilopascal. We're given a temperature of 28 degrees. We are here to determine the weight of the helium contained in the balloon. So, binigyan na tayo ng volume ng sphere dito just for our warm-up. So, ang volume ng sphere is 4/3 pi r cubed. Pero hopefully, you remember that intuitively naman. Okay? For at least yung mga basic shapes lang naman. Like yung prism, sphere, pwede rin yung pyramid. Okay? So, naglagay ako ng additional details dito kasi obviously, hindi available lahat ng ng uh, ng uh, ng details for helium. So, kung titignan mo, we are required to find yung weight. Take note, weight ng helium. And we're given temperature ng 28 degrees, tapos volume ng sphere, so kinuha ko na lang, hindi ko pa kinukuha, pero 8 meters in diameter with yung formula ng volume, and then meron tayong absolute pressure na 106 kPa, well, this is kilonewton per meter squared, okay? Now, from the appendix ng book, obviously from the pagbibigay ko sa inyo yung exam, bibigay ko na to additional details. Yung specific gas constant ng helium is 2.077 kilojoules per kilogram Kelvin. So from here pa lang, from the given pa lang, so ito yung given nyo, you would think na, hey, recall natin yung parang ideal gas equation problem to. We're given a temperature, we're given a pressure, we're given a volume na, and we're given R. So ang kailangan ko pala is yung PV equals to MRT. Props dun sa mga nakakuha sa error ko. So, tandaan nyo yung 1 point or 2 points nyo dun. So, pero recall na pag nilipat natin yung volume sa kabila, so divide natin sa mass, magkakaroon tayo ng P equals to density RT. Okay? Since we're being asked to hanapin natin yung weights, I just did it this way lang naman. So, in short, hindi natin alam yung density dito, yun yung unknown. Well, going towards mass tayo, and then eventually weight eh. So, kailangan natin yung absolute pressure divided by yung specific. So, in-arrange ko lang yung formula. In this case, hinanap ko lang yung density. So, density ng helium is equals to pressure absolute, and then yung specific gas constant ng helium, and then yung absolute temperature. Okay? Uh, it's probably hindi ganun yung route ng ginawa nyo, pero if we arrive at the same conclusion naman, that's fine rin. Okay? So here, I just write them down. 106 kilonewton meter squared, 2.077 kilojoule per kilogram Kelvin. And then of course, hindi siya absolute temperature pa yung 28 degrees natin. So we have to add 273. Okay? So after that, we cancel yung mga units na yan. Okay, cancel, Kelvin, cancel. Wow, medyo mabagal yung animation na din know. We will be left with, there we go. So may meter cube, may kilogram tayo. Tama. So 0.1696 kilogram per meter cube. And from here, makukuha na natin yung mass. So remember yung formula ng density equals to mass divided by volume. So mass is simply the product ng density and ng volume ng helium. We know na yung volume ng helium is 4/3 pi r cube. Remember diameter to, so ginawa ko, hinati ko lang siya. So magiging 4 cube. Meter cube, cancel yung meter cube, and you will be left with 44.46 kilogram. However, that is still not the final answer kasi we just multiply by the acceleration due to gravity, and we have, there we go. In this case, hindi na gumamit ng proportionality constant. Okay? So, yeah. Magiging 445, yes, 445.87 newtons or 446 newtons. Yes, sir.
Tanong ko lang po, pag po solving na ganyan. Although nakalagay po kasi for yung answer. Pero pag po ganyan na 445.87,
I'll
pag
accept it.
ibang way po, 75. Pag malapit na po ba, consider
Ano nakuha mong sagot?
0.75.
Well,
I mean, sir, pag hindi po i-round off ng exact, pag po yung mga items
yes. Like I said, do sa unang rule ko, okay lang naman yun. Basta yung, for example, decimal places mo is, yeah, okay lang sa akin yan. Okay, good. Okay, so, wait lang, sa yung PowerPoint. Okay, so just one example ng ideal gas equation problem natin, ano? Sige. Let's go for more. So, balik tayo dito. Okay, ano pa? So, ito yung helium. Okay, let's go naman with, okay, glycerin. Something exciting naman ng konti. Okay, so let's just click this up lang. Not sure kung gumagana to sa PDF, pero mga links na to, pero I'm not sure, hindi yata ganun yun, para naka-print siya as it is. So, anyway, ito naman. So, determine the mass of carbon tetrachloride. Okay, wow, carbon carbon tetrachloride that should be mixed with 80 kilograms of glycerine so that the combined mixture has a density of 1,450 kilogram meter cube. Huh. Binasa mo ng diretsong ganun. Parang papaisip ka ng ano daw. So, ulitin natin lang, ano? So, kailangan daw natin malaman yung mass ng carbon tetrachloride na imimix sa given na 80 kilogram na glycerin so that yung ending density natin, yung mixture natin daw, yung combined density ng yung combined mixture nila is yung density is 1,450 kilogram per meter cube. Okay, paano nga ba yun? Lista lang muna natin. Alright. So yung combined mixture is 1,450. Ito yung chemical formula naman for glycerin, MC3H8O3. That's 80 kilogram. But I'm fine pag nilagay nyo lang mass sub-glycerin, that's fine. I just wanna make sure lang naman. Baka kasi may mga gusto specific na, ito yung chemical formula. Pero okay lang na simplihan lang natin in the future. Of course, I think, not sure kung binigay ko sa book to. Wait, back pa to. Okay. Alright, so nag-provide ako ng additional details dito. So, hindi ko lang nakopya doon. Oops. So, nag-provide ako ng additional details naman dito, like yung density ng glycerin, yung density ng carbon tetrachloride na galing sa book. And just like sa just like sa exams, I'll provide rin yun. Kasi parang, come on, I don't know, I can't remember all of them. No? Alam ko lang yung water, and that's it. Like, even yung mercury, yun na yung pinaka-max. Okay? Okay, balik tayo. Okay, good. So, yan. So, kinuha natin from the book yan. So, yung density ng glycerin natin is 1,260 kg per meter cube. And then, density ng carbon tetrachloride natin would be 1,590 kg per meter cube. Okay? So, kailangan natin malaman is yung mass mismo ng carbon tetrachloride. So, ang solution natin. If you recall, yung density is equals to mass ng substance, or in this case, mass ng mixture divided by yung total volume ng mixture, okay? So, that would make sense na yung mass ng mixture is equivalent to the mass ng glycerin and yung sums ng mass ng glycerin and ng carbon tetrachloride natin. Ganun rin with its volume rin. Okay? So, kinuha natin yung volume ng given natin na glycerin. Okay? Kinuha ko rin yung volume ng tetrachloride. And then I just equate lang yung equations na yun, just like so. Para ang matira lang natin is yung mass ng tetrachloride. Okay? We have yung 80 over 1,260, mass 1,590, 80 plus m. And ang matitira natin dito, i-isolate natin equation ng m. And we have 137 kilograms. Now, okay, paano natin check to? Substitute 137 to dito sa density. And then solve natin yung volume. And then if yung density mo is 1,450, then you are, or it is close to 1,450, we're good. Okay? Now, yung mga steps ko sometimes may be of a longer method. Pero sometimes I realize na, hey, mas magandang ipakita ko yung longer way lang naman. Because yung shortcut can be down the line na lang naman eh. Okay? So it's important for me to break it down for you guys rin. Okay? So if you did this but in a much shorter way pero we still arrive with the same answer, that's fine by me. And as long as I read it and I understood it, sige. Pero pag di ko naintindihan, tatawagan naman kita eh. Paano mo nakuha to exactly? Okay, okay. Pag in-explain mo, that's fine. Okay? Pero pag maraming tanong, heck, ako pag-isipan ko kung consider pa yung question na yan. Alright. So, easy peasy lang, no? Almost direct substitution lang. So, ang important analysis dito, yung bulk ng work mo is actually nandito na eh. Nandito eh. So, nag-analyze ko muna ng given mo and then you establish yung equation na gagamitin mo. And then from there, is just execution na lang. And then, the rest is practice. Okay. Okay. Let's solve for more problems. So, we have this one. I'm sure iniwan ko sa inyo to kasi parang these are good problem solving rin naman. So makita niyo nagbigay ako ng additional details ah. And then meron ka dito na ito yung tank naman of unknown gas yata to. So, 'di ba? So in this case hindi binigay yung air, mass of air lang naman. So in this case, you assume yung R for air. Okay? So let's go for ito naman, a spherical balloon, 2.14. So ito yung example ko na may molar mass. So hindi ko siya binigay sa type ng seed perk pero I just wanted to show you ano bang conversion nito paano how we're gonna deal with pag may ganyan, pag may molar mass eh. So by the way, may answer na yan ah. So 31.3 kilomole and 125 kilograms, you know. So sabi dito, click natin, a spherical balloon with a diameter of 9 meters is filled with helium at 20 degrees. And then, so meron tayong temperature, 20 degrees. Meron tayong pressure na 200 kilopascal. Now, we're being asked to determine the mole number and the mass of helium in the balloon. Okay, obviously, you need additional details dito. We have to know yung molar mass ng helium, which is 4.003 kilogram per kilomole. And then, of course, yung universal gas constant, which is about 8.31447 meter cube pascal per kilomole. Okay, so paano natin gagamitin yan? So, let's just imagine, ito yung sphere. Meron siyang diameter na 9 meters. So, you can interpret yung given nyo as such rin, ano? You can draw it, whichever is comfortable sa'yo. Okay, we have yung temperature na 20 degrees dito, and we know na may pressure tayo na 200 kilopascal. Take note na 20 degrees Celsius na to, hindi siya absolute temperature. Okay? And hindi sinabi, I believe, ano ba sinulat ko dito? I believe in 200 kPa is, we can assume this is an absolute pressure rin eh. Okay, so we're here to find yung symbol ng symbol ng mole number ah. N, capital N, helium, and then yung mass ng helium. Okay, ito pa yung other givens natin. Oh. So we're given yung 8.31447. So I just converted it a bit lang para sakto yung cancellation natin later. So tinanggal ko yung Pascal, ginawa kong kilopascal, tinanggal ko yung mole, ginawa ko siyang kilomole para diretso dun sa pag-cancel pag ginamit natin yung gas constant eh. So this one is, which is technically the same pa rin naman, 8.31447 kilopascal meter cube kilomole Kelvin. And then we have yung molar mass, 4.003 kilogram mole. So, ang gagamitin natin, so ito na yung mga given natin, no? Okay. So, we know na may involved na mole. So, ang gagamitin nating formula instead of yung standard na PV-MRT, we can also use yung PV equals to nRT. Okay? And then ito yung conversion ng mole tawag dito ng mole number times molar mass to actual mass, okay? So yun yung silbi ng molar mass na yan. So multiply mo siya to yung molar numbers para makuha yung mass. Pero in this case, I think makukuha natin muna kaagad yung mass eh. Actually, makukuha pala natin muna dito yung number of moles niya. Okay? So, equate natin, i-rearrange natin yung equation natin further. Ang unknown natin is yung N. N is equals to pressure times volume divided by yung gas constant times yung absolute temperature. Okay? You substitute yung values as such. So, we have 200 kPa. Yeah, tama nga. So, pag hindi sinabing absolute temperature, you just assume You can assume na ideal gas siya, okay? And then you can assume na absolute pressure siya doon, okay? So, and then yung volume, which we remember na 4/3 pi r cube. So, meron tayong diameter na 9, radius niya is 4.5. So, 4.5 cube yan. Okay? And then, substitute na natin yung R, which is yung, in this case, universal gas constant. Since ang ginagamit natin naman involved dito, pag moles ang involved, we use yung gas constant. So, parang a bit background lang with your chemistry before, no? Then, of course, uh, yung sa 20 degrees. Okay, siguro, yeah, if you're gonna be anal about it, sa book kasi nilagay nila 273.15. So, I just followed it lang muna. Nung una kong sinolve to, hindi ko sinabay yung 0.15. Okay lang. Okay lang. Guys, kung hindi nyo sinabay yung 0.15, okay lang rin. Medyo magkakaiba lang ng konti ng sagot, pero okay lang. So, I just have to match it up lang doon. Okay? Sige. For the meantime, I'm just gonna follow lang yung book for the meantime kasi sample lang naman siya, okay? Sige. So magka-cancel out yung units as I prepared in advance. So kPa cancel, meter cube cancel, Kelvin cancel. So matitira dito is 31.321 kilomole. Okay. Sa mga nakasolve nito, pag hindi nyo ginamit yung 0.15, ano yung na-solve nyo? Can you do that? Actually, do that.
31.3.
Yeah, so yun. So yun. So technically pareho lang, okay? Technically pareho lang. Acceptable yun. Okay. Alright. So, for me, just to be safe lang, sige, lagay lang muna natin. I'll just explain it sa class na lang. So, again, 0.15 won't matter much naman na. Okay? Pero naman ang answer sheet dun, and then yung sinolve ko pareho, yeah, konti lang yung difference eh. So, wait lang, tanggalin ko. Lagay ko na nga lang dito yan siya. So, okay lang na kahit wala na yan, kahit 273 na lang yan. Okay? Sige. So, since konti lang pala yung difference eh, no? Pero for now, i-assume mo natin na may 0.15 yan. So, after nan, gagamitin na naman natin yung formula to convert tong number of moles na to into actually mass by multiplying it sa molar mass. Okay? So, mangyayari lang naman doon 31.3 or 31.321 kilomole, i-multiply natin sa 4.003 kilogram kilomole. And you would yield, so cancel yung kilomoles mo dyan, and you would yield 125.376 kilograms. Pag sinold mo siya with 273 lang, ano yung masa nakuha mo, sir?
0.44 po. Pero hindi ko po multiply ng molar mass
Try,
sa end.
sige, try, let's,
Yung sa akin po kasi, TVMRT po another po.
another formula. Okay.
Yung ano po, PBMRT po yun. Hindi ko po kasi alam na pwede pong multiply yung molar mass.
Ano,
So, nag-PBM.
okay. Okay. So, doon kita mamaliin. Pero nakuha mo may mas.
Up, yeah,
Ah,
125.44. Di po sir yung 4 mass po, di po pwedeng TVMRT po. Tapos
okay.
hanapin na lang po yung specific gas po.
Since given, nabigay ko naman yung R ng helium before, yun yung ginamit mo.
Tapos, tama po.
Technically pwede rin naman. Technically pwede rin naman actually. Maswerte ka na given yung R. Paano kung wala yung R ng helium? Doon tayo okay, okay, okay yung sinabi mo. Yes. Especially pag nasa problem naman, dito ako kinuha mo yung helium. Make sure na ilagay mo lang sa given na i-refer mo lang dito sige, nanggaling yung given na yun from another. Since yung specific gas constant naman, hindi naman nagbabago per problem. That's technically yung property ng gas. Sure, ilagay mo lang dito na, hey, nakuha ko yung R neto from this problem. Ito yung,
Yung ano po sir, if naloko po yung pag-formula ng specific gas constant. Yung universal over molecular.
yes, pwede mo rin gamitin yun. So, okay. So, yeah, actually, makukuha mo nga naman yung yung universal divided by, tawag dito. Sige, paano nga? Paano mo nakuha yung sa mole?
Mahaba lang po yun sir. Mas okay po to short.
Yeah, gets ko yun. Yung pag pwede mo makuha yung molar mass. So, in short, sinold mo to using yung given ng helium, specific gas constant ng helium, and then dinivide mo yung R na yon. para makuha yung kilomole?
Ano po sir, hindi po, same po nung NC ko to PDRT po.
Okay.
Tapos for mass po, kinuha ko po muna yung specific gas constant, yung 8.3447 divided by 4.003.
8.31447 divided by 4.0.
4.0. Same
Yeah,
rin po na lalabas po dun sa nabigay po sa initial,
ayun.
sa other problem. Tas
Someone,
hindi
someone,
po mark.
yeah, someone did his homework rin naman, ano. So, tama, tama si, what's your name, sir?
Dala yan po.
All right, 2 points, Angelo. Thanks for providing that. So, wait lang. Kita ko yung, wait, nasan yung, where's my pen? There we go. Yeah, almost, hindi ko siya in-include dito kasi parang hindi naman siya necessary. Pero, technically, without, kunwari hindi given yung R ng helium from another problem, technically, yes, you can get it using this lang, ano. Tama, sir. Ang ginawa mo is R helium is equals to universal gas constant divided by yung molar mass niya. Alright, and ano yung magiging result? You guys can
Same rin po na sa given, 2.077.
2.077. Units mo is equals to?
Kilojoules per kilogram.
Yeah, there we go. So kung mapapansin mo, tama, matitira yung kilogram, mawawala yung kilomole. Pam, pam. So, wait. Lagyan natin. 8.31447. So, meron tayong kPa dito. Meron tayong kilomole. Then Kelvin. And then meron tayong meter cube. And then, molar mass mo is kilogram. Tawag ito? Kilomole. Okay? So, technically, bababa to. So, pwede mag-cancel yan. Ito, kilonewton per meter squared to. So, matitira dito is what? Meter, ano? So, magkakaroon ka na lang ng kilojoules na lang dito. And then, yeah, matitira mo na lang is Kelvin, kilogram, and then whatever equivalent ng kilojoules. Talala mo sa akin, Angelo, ah.
Thank you po.
Okay. Eraser, yeah, there we go. So, good job, good job. So, kung makikita nyo, technically, nandun rin naman, ano? So, good for you for recalling yung basic chemistry. Pero nagbigay lang ako ng one problem kasi mas maganda madaanan nyo na lang. And thank you, Angelo, for explaining further na, hey, you can actually, even without yung given, pero pag given ka naman ng universal gas constant and a molar mass ng specific gas na yun, hey, you can get yung specific gas constant by just dividing yung R with its molar mass ng universal gas constant divided by yung molar mass ng specific gas na yan. Okay? Alright. Mula na sa akin din ulit. Hopefully safe kayo guys. Safe yung family members nyo and hope di kayo binabaharin or hope you guys stay dry. Okay? Anyway, so go back tayo dito. So that was fun, di ba? So, yeah. So, minsan may nagta-translate yung given na yun, pero if you manipulate well enough yung formula and you know yung basic principles ng some chemistry principles nyo, you get to figure it out rin naman eh. Either way, pag magbibigay ako ng problem rin naman, I'll still give pa rin parang, hey, additional details para hindi na kayo maghanap kung saan-saan eh. Okay? Sadly, sa board exam, sometimes nawawala yung additional details. Refer to table na ganito. Minsan wala. So parang nagkaroon yun ng issue eh. Way back noong 2014. So parang ang daming questions na ganun. So tinanggal nila. Out of the 100 questions, 30 problems yung ganun. So ano matitira? Ay, 40 pala. 30 or 40, either way. So parang 60 or 70 na lang natira. So binasa yung score mo dun sa 60 or 70. Tapos parang convert na lang kung nakuha mo lahat yung 70 na yun or 60, 100% ka. Pero tapos ko-convert na lang whatever yung tinama mong sagot nun eh. So may mga ganong klase nangyayari sa board exam. Funny. Okay. Alright. So, questions dito. So, basically, parang manipulation siya. Ang binigay ng book, wala masyadong parang ano yung density ng ganito, ano yung specific weight ng ganito. Kasi, naniniwala yata si Hibler and si Sengel na mas madaling gamitin natin yung fluid property principle pag bibigyan natin yung mga estudyante ng mga ideal gas equation problem. Kasi almost combination ng lahat yun eh. Nandun yung pressure, nandun yung volume, nandun yung mass, and then meron ka lang constant na kailangan mong tandaan, or usually given naman. And then meron kang temperature, which ko-convert mo lang into absolute temperature. Usually naman, pag hindi sinabi sa problem, yung pressure, kunwari, sinasabi minsan, absolute pressure 160, pero tulad nito, hindi sinabi. So, you can assume na ideal gas naman siya. Okay? Remember, yung ideal gas naman, hindi siya nag-work sa extreme temperatures, hot and cold, and extreme pressure. So, this appears naman to be normal condition, normal ideal equations naman eh. Alright, moving forward. So, meron tayo yung viscosity problem. So, ito usually pag nagbibigay ng viscosity problem, ganito yung tsura niya rather than yung sa viscometer, okay? So, I'll just walk you through lang kung paano and usually given as a mathematical equation. Eh. Okay, ipapakita ko lang kung how. Not sure kung na-correct ko siya right now. Pag hindi ko na-correct yung notes ko dito, skip ko lang muna. Tapos pakita ko na lang later. Okay? And then we'll be dealing with, ito madali lang to. Since parang literal direct substitution lang to with yung given formula natin for capillary rise or drop ng surface tension equations natin. Okay? So let's deal with muna tong plate na to. Makikita nyo naman kung saan ko kinuha to. So, ito, in this case, may hindi ako natanggal, sorry. Nandyan, hayaan nyo na lang muna dyan. Huwag nyo pansinin yung nakasulat dyan. So, sinulat ko to, kinuha ko to kay Hibler. Nandun siya sa Fundamental Concepts, page 41. Okay, so we have here yung plate. So, yun. So, merong isang moving, merong stationary. Remember, pag moving, so moving rin yung top layer ng fluid na to. And gradually, nagdi-decrease siya kasi meron tayong tinatawag na no-slip condition. So, kung 0.32 meters per second yung velocity natin dito, zero siya. So, yun yung zero U natin. Okay? Okay. So, meron tayong plate dito that rests on top of a thin film of water. Ay, dito ba yung nagtanong about thin film fluid dynamics? O sa kabilang section yun? Yeah, sa kabilang section yun. Tapos, so meron tayong at a temperature of 25 degrees Celsius. Not sure kung kailangan natin, pero probably not. Sinasabi lang naman usually yung temperature pag sinasabi, okay, almost parang atmospheric conditions lang. At normal, at standard temperature pressure lang. Eh, naglalaro tayo between 20, 25, 24. Eh. Okay? Uh, if a pressure difference occurs between A and B and a small force F is applied to the plate, the velocity profile across the thickness of the water can be described as U is equals to the 40 y minus 800 y squared meters per second. Oops, Diyos ko po, bakit may math equation sa isang velocity? Okay, hold lang, hold lang. Okay, may explanation yan. Okay, just like any math problem, pag hindi nyo na-recognize, okay lang. Okay, daanan natin para makita nyo kung paano niya sinolve to. So, where y is in meters. Okay, so y yun. Determine the shear stress acting on the fixed surface and on the bottom plate. So, gusto niya malaman lang naman yung shear stress sa fixed surface, dito, and wait lang, acted on the fixed surface and on the bottom of the plate. So, bottom of the plate, medyo nakakalito lang yung kanyang English ng konti. So, yung fixed surface, ito yon. Yung bottom of the plate, ito yon. So, yung dito. Yung shear stress dito, and then yung shear stress dito sa surface na to. Okay? So, let's take yung muna yung given natin. Okay? Baka kasi huwag tayo magpa-intimidate sa product. Nakita lang tayo ng equation sa velocity. So, I believe, nagbigay ako ng density ng water. Well, mu ng water. Bigay ko ba dito? Ay, wala nag-return. Oh, hindi ko nalagay yung mu ng water. Okay, sige. Anyway. So, yeah. So, nakalimutan ko ilagay na, hey, kinematic dynamic viscosity ng water is 0.897 10 to the negative third Newton second meter squared. Okay, so nakalimutan ko siya ilagay doon pero it's best na alahanin lang na at least yung water man lang, okay? So water is 0.897. So yun yung missing information dito. That's fine, that's fine. That's my bad. Kaya hindi ko siya binigay as an example as a seat work eh. So hence meron siya kaya may 25 degrees dito. So galing siya sa from the book eh. Okay, so pero pag sa problem naman, pag sa test ilalagay ko yung okay, ito yung viscosity ng water at 25 degrees Celsius. Okay, so yan yung given na natin, okay? So, you're given, meron kang velocity profile, U. 40y minus 800y squared. And then meron kang thickness dito. Pangalan natin L na 10 millimeter. And of course, a force F, whatever man yun. Okay? Ang kailangan natin malaman dito is yung shear stress acting on the fixed surface. This one. And this one sa bottom ng plate. So how do we do that? So ito yung symbol ng stress natin, ng shear stress natin, tau, EAU, or yeah, I believe yun yung spelling niya. Please correct me if I'm wrong. Recall that yung shear stress is yung dynamic viscosity times yung velocity gradient, du dy. Remember, this is yung velocity profile. Non-derived pa siya. So, meaning, i-differentiate mo pa siya, okay? Just bear with me lang, bear with me lang. Okay, do not be intimidated with this du dy thing, okay? So, ano ba yung silbi nan? Remember, ito, so pag nag-derive ka dyan, mag-equivalent niya is 40 minus 1,600y s to the negative 1. Diba? So, ito yung gagamitin natin equation. Ito yung derive, ito yung equivalent niya, okay? So, kailangan lang natin malaman muna is yung from the non-fixed plate. So, from here. So, obviously, yung velocity natin, so, yung velocity natin dito is 0 eh. Remember, lagyan mo na ng 0.1 and 2 to. Okay? 1, 2, 1 minus 2, 1 minus 2. Okay? 1 wherein 0.1 mo may moving velocity ka, 0.2 mo is yung usually yung fixed surface mo. Okay. So yung y na to, ito rin naman yung 10 millimeter. Sorry, nilagay ko na lang as L, dapat y ko na lang nilagay. So ang ginawa ko na lang dito, we just substitute lang naman yung y. Okay. So ito yung from the non-fixed plate. So ito siya. So yung distance dito is 10 millimeter or 0.01. I simply substitute it lang dun sa y value ng 1,600y. And then if you would, multiply them all together, you will just reach yung 21.5 megapascal. Now, tuloy ko lang. Pag naman sa fixed plate naman siya, so fixed point, dito tayo. So, obviously, walang thickness yon. Magiging 0 siya. So, y is 0. So, 1,600 times 0 is 0. So, yung shear stress at fixed mo is 35.9 megapascal. Any questions? If anything,
Sir, bakit po naging
actually over seconds yan eh, to be honest with you. And then yung meters mo cancel out kasi pag nag-derive ka, mawawala na yung meters mo dun. Okay? So technically 1/2 to. Si Angelo ba yun yung nagtanong? Same voice eh.
Sir Cruz?
Jerome. So yeah. Uh, yeah. So somewhere along the lines, nag-cancel siya pa nag-derive siya and matitira is yung 1/2 na lang or second raised to negative 1. And then, ito yun yung gagamitin mo equation para i-substitute lang at thickness ng 10 millimeter and then at thickness ng 0 millimeter. Okay?
Okay po, sir.
And then, guess what? I'll research a better answer for you, Jerome. Kasi nung i-check ko siya, same rin yung tanong ko kay Hivler. Saan mo tinanggal, saan nawala yung meters? Nisip ko, wait, maybe nag-cancel yung meters na yun somewhere along the line. Kasi technically, yung Y na to, ang unit nito is technically meters rin naman. Baka nga naman ganun, di ba? Kasi Y is referring, basically, we're talking about dito, pag binasa mo siya in English, change in velocity with respect to change in yung in-between thickness na to. So if we're gonna put units there, we're gonna be anal about it na ng konti. This dy has a unit ng meters, technically. Diba? And for now, I think yun muna yung pinaka-conclusive analysis, yung hypothesis ko dun. Kaya na-cancel out yung meters. Okay? In this case, once nakuha mo na yung differentiation naman na, is merely direct substitution naman eh. So, this kind of problems, uh, bibihira. Pero once na nakita nyo na, okay, alam ko na kung paano gawin to. Binigyan ako ng equations, ito yung velocity profile. Tapos, para makuha ko yung velocity gradient, kailangan ko siya i-differentiate lang. So, mapapansin mo na wala yung y, 40. And then, yung 2, bumaba lang dito, maging 1,600. And then, naging y na lang siya. So, maalala yung konting calculus eh. If ever man, yun yung pinaka-max calculus natin dito. That's it. That's it. At least for this lesson. Okay? Sige. Next. Ano ba next ko dito? Ang next ko naman dito would be, so gets to, so more or less direct substitution lang naman. It's a lot simpler dun sa example ko dun sa viscometer, no? So, yeah, I won't be putting that sa paper kasi pas malala lang kayo marito dun sa problem eh. Okay? Alright, next one naman is about yung, so surface tension problem naman tayo. Not sure kung makaka-recall nyo pa yung yung surface tension equation. Pero basahin lang muna natin yung problem. So, meron tayong 0.6 millimeter diameter glass tube. Tapos is inserted into water at 20 degrees Celsius in a cup. Determine the capillary rise and water of figure 2-39. Wait lang. Usually pag ito kinakabahan ako, 20 degrees water. Normally kasi for water properties, meron siyang sariling dynamic kinemosity, dynamic viscosity, kinematic viscosity, and then meron rin siyang surface tension, water, given eh. So I don't think nabigay ko yung given ano. Yeah, hindi ko nabigay yung surface tension ng water. Buti lang hindi ko siya binigay na sample to, no? Anyway, punta tayo dito. So in this case, hanapin natin yung given lang from the book, which I will provide naman in the problem, okay, or during exam naman. So for water at 20 degrees, surface tension ng water is 0.073 Newton meter. Then of course, density ng water is 1,000 kilogram per meter cube. Okay? So in this case now, we are asked to determine yung capillary rise of water in the tube. So H, basically yun yung formula ng H, ano? Yung H ang hinahanap natin. Capillary rise ba or drop to? Okay? So we're given yung diameter na 0.6 millimeter. So divide na lang natin by R yan eventually. So ang solution natin, kung ma-recall natin yung ng capillary rise or drop is simply 2 times yung surface tension, omega, I believe it's omega, divided by density times acceleration due to gravity times yung R, or radius. Okay? Not sure kung ba dinivide ko by 2 to, pero dapat dito pala ako dinivide yan. Ano? So, radius to, by the way. Tapos, times cosine phi. Alam natin, pag water, it's usually 0 degrees. Okay? Pag hindi binigay, tapos water nakalagay, and then walang binigay na angle, that's 0 degrees. G is 9.8066, and then water is 1,000 kilograms. Okay? So, we just plug and play na lang dito. Right. We can probably have a modification lang siguro pagdating sa R natin dito. We can just make this parang radius lang, like we should. Kasi pag R, makakalain natin gas constant, no? Sige. Okay? So, multiplying everything dito, so 2.0070 Newton meter plus 1,000, 9.81 meters squared, 0.062 times 10 to the negative third meters. Okay? Kasi naka-millimeter siya eh. So, yan. So, yung conversion lang nun. Cancel. And then, times cosine 0 degrees. And then, nagbigay lang ako ng, ang tawag dito, parang proportionality constant para ma-convert ko yung, ma-cancel out ko yung yung respective units like newtons, tanggal yan. Kilogram, meters, tanggal yan. And then matitira lang dito would be isang meters dito. So matatanggal rin yung second squared. So 0.05 meters or mas magandang sabihin natin as 5 sinks. We're dealing with small units lang naman. Okay? Binigyan ba kayo ng proportionality constant na ganito nila Sir Almira nyo? Or iba? The one yun?
Baka po nung first lesson po ng thermo.
First lesson ng
Matagal.
matagal na pa yun. Sige. Okay. Anyway, so dito lalabas yung proportionality constant. Okay? So para ma-cancel kasi pag ginawa mo to, pag di mo tinignan, pag di mo minultiply ito, ano matitira mo dito? Base lang dito. So we have meter cube. Technically pwede rin naman no. Okay, what else? Ano ang newton ulit?
Kilogram meter.
Meters. Ay, di pala siya proportionality constant. It's just simply minultiply niya lang mawala yung newton para magpakita ito. Okay.
Sa English, bata ni
Yeah. Okay, ulitin ko. So, wala pala yung proportionality constant na yan. So, it's just simply reverting yung newtons to yung base form niya, which is kilogram meters per second squared. So, from here, magka-cancel out na yung kilogram second squared. And ano matitira? Wait lang. Ilan?
meters.
Wait. Meter. Yeah, dapat maka-cancel to. Yeah. There we go. Dapat maka-cancel kasi meter cube to 1, 2, 3 meter cube there. And matitira tong meters na to. Yun. There we go. So matitira is meters. So you will have 0.05 meters. So ulitin ko, okay? So ang ginawa niya lang naman dito, alam natin is Newton is 1 kilogram meters per second squared. So ako yung nag-solve nito. Nakalimutan ko yung paano explanation eh. Anyway, that happens. So kaya parang nireflect niya lang dito yung kilogram meters per second squared. You can also do that para lang makita mo yung cancellation of units. Okay? Malinaw dito kung bakit mayroong 1 kilogram meters per second squared. Give me a thumbs up if nagets yun. Good. Sir, ask ko lang,
Sir,
kung i-upload din po yung mga sinagutan sa Canva. Aaron, sorry, hindi ko napansin yung question mo. So, ano yung, ano yung nire-refer mo? Yung ba yung ano?
ito po. Today ba yung
Yes, na-upload ko na.
pag-post?
Okay. Sorry, may gusto may tanong kanina. Na-cut off ko siya kanina eh. Sorry. Is that you, Jerome?
Yung,
Yes, Angelo, yes.
sir, yung yung kasunod po nasa problem. Ano po kasi siya, sir? English tapos isa pong naka-SI. Ganun po ba talaga yan? Kami po ba magka-convert? Or bibigay rin po yung
Wait lang.
English?
Wait lang. Yung susunod na problem nito. Wait lang, balikan
Yung
natin.
po,
Bigyan mo yung,
surface tension niya, sir, for
e-
SI.
eto
Tapos the
ba?
rest po nung
Eto ba?
table. Yes po, sir.
Yes. So, yeah. Binigyan ko yung English, ano? Kaya nyo yan! So, yung isa metric, di ba? Ito, yung 1.2 meter diameter tube. Tapos naka 960 kilogram meter cube. Yung 2103, kayang sagutan, di ba? Determine lang naman yung surface tension ng liquid kasi
Tapos,
so given na kayo ng angle, dali na lang yan. Tapos yung
yung
2105E,
tumutukan yung po.
yeah, kaya niya yan. Di ba enough yung details na binigay ko?
Need pong, need pong gumamit ng sir, conversion back.
We'll see na lang, okay? I just wanna see kung paano niyo i-play yung formulas doon. And then Then, if di nyo magets, sige, we'll see na lang, okay? Just try to solve it lang muna doon. Okay? Huwag kang kabahan, Angelo. Kaya mo yan. Actually, kaya nyo yan. Okay?
Pero pag po, ano po, okay lang po if may discrepancy.
Yes,
Like
yes.
17 ako.
For this particular seek word, ang purpose lang naman natin dito is really for you to practice yung equations nyo dun. Okay? And then, if ever may mali, okay, let's see yung mali nyo, okay? I'm not gonna judge you based kung mali or tama yung sagot nyo. I'm gonna judge you, well, technically, dapat I should judge you there. I'm gonna judge you kung tama yung process flow nyo dun. Kasi if, if I'm gonna make sure na, hey, ganito dapat yung solution nyo, ganyan, you're gonna be boxed in lang eh. Diba, Angelo? So, I'll let you play out lang muna yung equation mo dun, and then let's check na lang. Okay? Alright. So, kaya ko siya sinama na, hey, binigyan ko, baka masanay kayo sa puro metric eh. Huwag niyong kalimutan si English. Hey, may English tayo. So, tingnan natin kung paano niyo susolve naman siya pag English naman na. Technically, it's the same formula. It's just that in English. Okay? Ano ba ginawa ko dito? Wait lang. Gusto ko na makita eh. So, gusto ko kayo bigyan ng clue kung paano ginawa, paano ko siya ginawa. So, 2105E, ano? Paano ko nga ba ginawa to?
Correct po, try to mami po.
Yeah, yeah, maybe. You're getting warm dun, yeah. Yeah, kaya nyo to. Hindi ko na kailangan pala ibigay yung tool. So, yeah, kaya nyo to. So, sinabi mo na rin yung clue eh, proportionality constant eh. So, nandun na yun. Okay, saan tayo
Yan
natap?
lang po siya. Hindi lang po ako sure dun sa conversion po ng surface tension.
Ka
Baka mali po yung
Hindi, kaya isa-isayin mo lang yung units. Kaya nga tayo, ang unang problem set natin is yung yung ganito para ma-practice. Okay, paano tayo mag-cancel ng mga units? Eh? Paano ba mag-cancel ng mga equations na to? Pero it's not exactly fluid mechanics related, pero it's a good warm-up. It's definitely a good warm-up. Okay, ano yung next natin dito? Saan tayo nag-stop? Dito tayo nag-stop, ano? So that's easy peasy. And then, i-return tayo. Nakalimutan ko i-return to dun sa second page. My bad. After nito, eto tayo. So, eto naman, gusto lang bigyan yung profile nito. Another type of example lang naman ng viscosity problem. Meron kang fixed wall, and then meron kang moving wall, and then merong plate na dumadaan in between. So, essentially, fixed, moving. Paano yun? Okay, puntahan natin yung problem. I believe nabigay ko lahat yung given naman na dito. So, there we go. So for this problem, we assume two things. Yung thickness of the plate is negligible dito, guys. And number two, the velocity profile in each oil layer is linear unless otherwise specified. So, okay lang to assume those. Now, we know for the force is being pulled horizontally just like so. And then, but we also know that there are two velocity involved. One, the plate itself at 3 meters per second and the moving wall at 0.3 meters per second. So, i-reflect natin yun. Okay, so, sometimes inuulit ko yung drawing para ma-analyze ko eh. So, ito yung moving wall, pero pabaliktad, 0.3 meters per second. So, moving yan ha. So, meron kayong plate at 3 meters per second pag ganun siya. And then, meron tayo yung fixed wall, okay? Let's just call it orange na lang, okay? Hindi ko na kinulay yung moving wall eh. So, yung orange na to, yung fixed wall. Tapos, may kanya-kanya silang thickness, 1 millimeter and then 2.6 millimeter. Okay? This tells us that there will be also two velocity profile and then two velocity gradients, of course. So, at least on that end, alam natin na hey, magkakaroon ng iba yung profile nito kasi pabaliktad siya. And then iba rin yung profile nito kasi una sa lahat, pakanan siya, ito pakaliwa. So, mag-iba yung itsura ng profile. When I say yung profile, yung basically parang triangle representation natin yun. No? So, para natin gagawin yun. So, the velocity profile from the fixed wall is easy. Madali lang yan kasi alam na natin, no slip condition. So, si stick dito, idadrag niya yung ibang liquid dito, iba yung velocity profile dahan-dahan eh. Hanggang papapalapit doon sa moving plate eh. So, more or less yung itsura niya pag ganito. Okay, nasa na yung drawing? Yeah, most like, yeah. So, ganyan. So, towards the right, most likely ganito yung velocity profile niya. Now, however, the other wall plate naman is moving in the opposite direction. So, ito this itong moving wall na to is moving on the separate direction. Ito kumokontra to. So, iba yung nagge-generate ng velocity profile naman on this area kasi ito pakanan. Ito naman, iba yung generate nitong velocity profile kasi ito pakaliwa. Paano magiging itsura nun? So, in a way, magkakaroon ng point dito. So, may nagtanong sa akin previous class na hindi naman ganyan yung itsura ng fluid. Tama kayo dun. Pero at least dito, sobrang idealized pa rin eh. Parang sobrang, parang simplified pa nga eh. No? The fluids, kung lalagay natin siya ng parang direction or arrows, it usually swirls eh. And normally, this happens rin naman eh. Lalo na kung mayroon akong pinapadaan instrument sa loob ng isang piping, sa isang pipeline, may nangyayaring ganun eh. So, kailangan lang mo lang malaman doon, ano ba yung mga forces involved lang doon, gaano kabilis. Baka naman kasi, ang pakay mo doon, baka naman maging sobrang turbulent yung flow naman doon. For our purposes lang, para ma-represent yun, ito yung simplified phenomena na nangyayari. Okay, paano kung may gumagalaw na plate ka doon? Okay? So, ito yung nangyayari. Ito yung mostly magiging insurang velocity profile kasi ito yung sa no-slip condition. And then dito, eventually, magkokontra yung 3 meters per second mo at yung 0.3 mo, creating this another velocity profile. So, ayan. Okay? Next. So, alam natin dito yung velocity niya 0 kasi fixed siya eh. So, meron no slip condition eh. And dito, ito yung parang difference na nila eh. So, magkakaroon ng, maglalaban yung dalawang velocity profile because one is going to the right, one is going to the left. So, na yun, nagkakaroon ka ng another height dito, A, at point A na to. So, titignan mo, actually, di ko na pinapasolve yung A sa inyo dito. So, more like, ako lang yun. So, kung na-practice nyo siya, kung na-gets nyo, that's good. Pero, ang ano lang naman dito, since we assume yung velocity profile to be linear, we can determine yung, yung thickness na to, or yung space in between ng point A and ng moving wall, via similar triangle rules. If you recall yung similar triangle rules nyo, simple ratio lang naman yung triangles yan eh. So, 2.6 YA is equal to yung height nito, and then yung 3 meters na to, 3 meters per second mo, ito rin yung, ito yung kanyang ratio rin. So, 3 divided by 0.3. Okay? And then, makukuha mo na yung YA nyo doon at 0.02364 millimeter from the moving plate. Not exactly necessary naman for the equation, pero it will be necessary to determine yung force needs to be applied on the plate to maintain this motion. Okay? Anyway, balik tayo sa problem ulit. So, medyo na-excite lang ako dito sa explanation ng fixed wall and moving wall. Eh, no? Now that we know na yung dimensions natin doon, yung thin plate natin dito is 30 by 30 centimeters. Being pulled horizontally 3 meters per second through a thick 3.6 millimeter oil layer. So, yan. Kaya ako nalaman ng 1 millimeter dito, 2.6 kasi given na siya. Okay, so dito yung 1, total niya is 3.6. Okay? And then two plates, and then one stationary and the other moving at a constant velocity at 0.3 meters per second. Shown in the figure below. So ito siya. So ito yung given na. Ang wala lang natin dito is hindi natin alam yung velocity profile and hindi natin alam yung na-create na thickness na to sa kontra ng 3 meters and 0.3. Now, binigay na sa atin yung dynamic viscosity ng oil at 0.027 Pascal second. Assuming the velocity in each oil layer to vary linearly, so yung A, nakuha na natin yung velocity profile and find the location where the oil velocity is 0. So, two locations na naman yun. One is here and then another one is here kasi nga nagko-kontra sila. So, we did that na. Okay, and next, ang kinahanap naman natin, determine the force that needs to be applied on the plate to maintain its motion. O, kailangan natin malaman yung force F. Okay, gagawa tayo ng konting algebra dito. Remember na find force. Basically, yung involved force lang naman dito is shear forces. Or shear stress for that matter. Shear forces. Pag may shear force ka, meron kang shear stress involved. Okay? Where yung F mo is yung shear force ng upper plus shear forces ng lower. Recall that yung tau is force over A, which is also equals to dynamic viscosity times the velocity gradient. Okay? Given yung velocity, given yung dynamic viscosity natin, which is at 0.027 Newton second per squared. Now, we can arrange na yung formula na to into such manner. So, lumalabas na yon, yung force natin is equals to, can also be equated to mu times yung velocity gradient times yung area. In this case, given naman yung area. So, we're talking about naman yung flat plate eh. Okay. So, pwede natin equate dito yung force ng up versus force ng lower. Ano lang naman, we just simply, tawag dito, substitute lang naman yung values. Again, so, substitute lang muna natin, alam natin, mu is given, 0.07. Area is given, madali lang yan kasi 0.3 by 0.3. Okay, dito tayo magkakaiba ng konti pagdating sa gradient. We know na ang equation natin dito is yung moving minus yung stationary. So, magiging 3 minus 0 meters per second siya. Okay? Tapos, kinonvert ko na lang into tapos yung 1 millimeter dito, ito yan, yung H. Yung dy mo yan eh. So, ito yung dy mo. So, yan yung 1 millimeter mo dyan. So, kinonvert ko na lang into meters. Okay? So, 3 meters per second minus yung 0. So, yun yung velocity gradient mo sa upper. Okay? So far, so good. And then, magka-cancel out yan. You would get 7.29 newtons. Pag gagawin naman natin yung lower, ganun ulit. So, mu, 0.027 times 0.3 times 0.3, yung area. And then, ito naman, dito na yung lower. Yung lower, ito yung lower part ng plate. So, we're talking about yung 3 meters per second and then yung 0.3 dito. Okay? So, ang pwede natin gawin, 3 minus yung opposite direction ng 0.3 meters per second dito is negative 0.3 kasi opposing forces siya eh. Okay? Opposite direction siya eh. And magkakaroon ka ng 3.084 newtons. Okay? Medyo, is it less intimidating na pag nakikita nyo yung du dy? So, yung dy lang naman dito is, ito ulit yun, 2.6 mm, kinonvert ko lang to meters. Okay, ito yung dy ng upper. So, ito yung 1 mm, 1 mm. Ito yung lower, 2.6, 2.6. Ito yung velocity gradient, du. So, 3 minus 0. Ito naman yung sa upper is 3 minus 0. And then sa lower naman, we're dealing with 3 meters per second minus yung minus negative 0.3 meters per second. So, applicable pa rin yung sense of direction dito. So, binigay ko lang siya sample kasi it's nice na alam nyo na paano siya dumaan dito. And Hibbeler and Sengel is punong-puno siya ng mga problems na parang may mathematical equation doon. Pero at least dito, pag nakita nyo siya, one of these days or maybe hopefully hindi naman sa board exam, hey, alam ko na yung paano gagawin dito kasi tinuro sa atin to ni sir. Hindi para tayo masyado magde-derive. Usually, mag-algebra pa rin tayo. Okay, unless merong equation dito, that's the max. That's the max derivation na kailangan mong gawin doon. Okay? We have, I believe, 2 more problems na lang. So, balik tayo dito. So, ito siya. So, velocity profile, optional. Baka hindi kasi magets. So, next dito is, okay, dalawa na lang. 2.79 and yung 1.47. Ito medyo exciting to. Kasi, kaya natin isolve yung A eh. Determine yung force needs to be applied. Direction na yun. Tapos yung next question naman dito is what if merong oil dito eh. So, let's go with the problem lang muna. Paano kung binigyan kayo ng ganitong klaseng problem? May konting statics. Hopefully, you still recall yung statics nyo with your Sir Edward. So we're given a 50 by 30 by 20 centimeter block weighing 150 newtons and is to be moved at a constant velocity at 0.8 meters per second on an inclined with a surface friction coefficient of 0.27. Doon pa lang you got clues na okay, we get the weight, we get the velocity, and we're given a friction of coefficient. So mayroong frictional forces involved. So A, determine the force F that needs to be applied in the horizontal direction. Okay, that's easy. Kailangan lang natin isulat yung FBD, alamin natin yung forces, and then alamin yung horizontal force na yan in the horizontal direction. So F. And then B, if a 0.4 millimeter thick oil film with a dynamic viscosity of 0.012 Pascal second or Newton meter second is applied within the block and inclined surface, determine the percent reduction in the required force. Oh, so medyo iba yung konti So una, basically we're establishing yung base force natin Tapos sa pangalawang tanong, okay, pag nilagyan natin ng oil para mapadali yung trabaho, ano yung percent reduction required ng force natin na yun? So sometimes, mas magandang tagalogin mo muna para maintindihan mo lalo yung question no? And and then from there, okay, you can now start solving yung problem. Ako, I start with given. I know na meron akong dimensions ng length, width, and height. Meron akong velocity na 0.8. Meron akong coefficient of friction, small f. I think yun yung symbol for coefficient of friction. Yung f na may buntot. And then 0.027 yan. And then alam ko yung weight ng block which is 150 newtons. So we're asked to find two things. Yung force and then yung percent reduction pag na-apply yung percent reduction ng force pag na-apply yung oil naman na. Okay? So of course yung solution natin, let's recall muna yung statics natin. Let's draw yung FBD or free body diagram. So we have yung inclined plane na to and yung mga forces niya. We know na yung weight is 150 newtons is pointing downward, dang. And then meron tayong coefficient of friction daw. So kontra yon lagi sa block along the inclined. So dito yon. So tatawag dito, on an inclined surface, on an inclined surface with a friction coefficient of 0.027. So on an inclined surface, ito yung most likely ito yung frictional forces niya. And then we're given an angle elevated at a 20-degree angle. So pag tinira natin ng ganyan, similar angles to, 20 degrees to. Then obviously, nakatouch siya on a solid surface. So meron rin pang kontra yung meron yung reaction yung inclined surface mo. So don't forget yung normal force mo dito. Okay, and that's 20 degrees rin yan. Now, if you recall yung equation of equilibrium ng particle or a body nyo, you know na yung summation of forces ng x and y would be equal to 0. So, nilatag natin sa x forces muna natin, yan yung equation 1. Nilatag natin yung y forces natin, yan yung equation 2. So, for x forces or horizontal forces, essentially is F, yung hinahanap natin, minus yung friction. So, FF, ginawa ko na lang ganyan. And then cosine 20 degrees. And then, of course, yung normal force. So, we're gonna talk about it. That's about sine 20. Ito yun, from the incline. Yeah. And then, what else? Equals to 0. And then for the y forces naman, we have yung Fn, yung normal force, cosine 20. So, ito siya. Bam. And then, minus sine 20, yung frictional force. And then, of course, minus W equals to 0. So, you solve lang din. Remember, the frictional force natin is coefficient of friction times yung normal force. That's equation 3. So, solving Fn via equation 2 and 3. So, it's more of recall lang to Okay, if hindi nyo alam, you probably have to Google, ano nga ba equation ng frictional force natin? Coefficient of friction times yung normal force niya. So, in this case, madali na lang siya. You get yung normal force, which is yung 150 newtons divided by yung translated equation natin from 2 and 3. And you would get 177.023 Newton. Okay? Now, we solve naman for the other parts. So, we solving equation 1, using na yung na-solve natin bagong answer dito, we would get yung force natin at substituting in values, we will get 105.459 Newton. So, ito yung sagot natin for A. Woo! So, yan yung base force natin. Okay? Or in this case, 105.46. Okay. So, lipat natin. So, alam na natin yung force natin is 105.459 newtons. So, paano naman daw pag may 4.40 millimeter oil dyan? So, recall, may oil dyan. This time, merong oil dyan. Sabihin natin oil yung blue line na yan. We apply ulit yung FBD natin. And then this time, meron na tayong tinatawag na shear force. Napalitan ng frictional force ng shear force. Kasi we have yung oil na eh. Okay, so parang medyo na-lubricate na siya ng konti. Pero obviously may forces involved pa rin naman dun, and yung force involved dun would be shear forces na. Hence, dito na natin magagamit yung thickness ng oil, dito natin magagamit yung dynamic viscosity. Okay, let's solve it. So remember itong part na to, basically pag in-expand ko, ito rin siya eh. So meron tayong force dito, meron tayong na 40 millimeter dito, and obviously meron tayong mini-maintain na velocity. Yung fixed dito, yung inclined plane, and then ito yung portion ng box. Okay, ito yung portion ng box. So, ng block. So, yun yung moving. Essentially, ito rin yun eh. So, we have yung moving velocity dito, we have yung fixed dito. Okay? So, how do we proceed from here? We're now gonna solve for B. How do we do that? So, obviously, alam na natin yung given natin dito, and alam natin yung operating area ng oil. Magandang alamin natin yung area kasi gagamit tayo ng formula ng shear stress is equals to force over area. Pero, of course, yung shear stress natin is equals to the product ng velocity gradient times yung dynamic viscosity. So, 0.5 by 0.2 lang naman yun kasi we're talking about yung length, width, and height lang naman yun. No? So, ito yun, 0.5 and 0.2. Yeah, so recall yung forces natin na ganyan, and then we can equate yung equation natin just like so. Yung force natin is equal to dynamic viscosity times yung area covered, area sheared, times yung velocity gradient. So, 0.012 times 0.5 times 0.2. And again, yung velocity gradient. So, simula tayo sa du. Moving natin is 0.8 minus yung non-moving. So, 0 yon. And then yung space in between is 40 millimeters. So, that's 0.04. And you would get 2.4 newtons. Di pa tapos si equation kasi uh, we need to know yung percent reduction, ano? So for new force na. So ito kasi yung shear force na dito eh. So babalik tayo dito, alamin natin ano yung bagong applied force na. Ano yung applied force on the horizontal direction. We just simply replace yung frictional force with yung shear force, and we would get, yeah, so follow lang yung equation na yun. We can get yung normal force. Now we can get na yung shear force, yung force applied horizontally at 57.2. So ang percent reduction is ng force no oil minus force with oil divided by force no oil times 100%, and is equals to 45.78%. Questions? What's this? This is yung triangle, ano? Alright. Page 66, ano? May gusto lang ako tignan lang saglit before we move forward lang. Okay. Page 60-79. Good. So, malinaw naman kung ano yung dimensions sa ginamit, ano? Bakit 50 and 20? Obviously, this is referring yung height din dun. Buti na reflect yan dyan. So, yung covered naman dito is yung buong surface na nakahiga lang naman yung block dyan. Okay. Last problem. Finally, another viscometer. Ito na naman tayo, sir. No, promise, this is a lot simpler than the last time naman, you know? If ever magpakita ako ng ganito problem, most likely ganito siya. Okay? So, promise, sobrang dali lang na ito pag nabasa nyo. So, the tube rests on a 1.5 millimeter thin film of oil having a viscosity na 0.0586 Newton second meter squared. Okay? And then, if the tube is rotating at a constant angular velocity of 4.5 radians per second, determine the shear stress in the oil at radius 40 millimeter and at radius 80 millimeter. Assume the velocity profile within the oil is linear. Okay, so we're just gonna simply know yung shear stress at 80 millimeter and shear stress at 40 millimeter. Paano natin gagawin yun? So we identify first muna yung given. We know na meron tayong dynamic viscosity. We know meron tayong angular velocity na rin. Ay meron din tayong inner radius 40 and meron tayong outer radius na 80 millimeters. So naka-represent as such, okay? Okay? And then meron na rin tayong 1.5 millimeter na thin film ng oil. So yan yung thickness natin or yung Y. Sabihin natin Y na lang yan. Recall, yung solution for shear stress is simply dynamic viscosity times yung velocity gradient. In this case, we can replace yung du dy as dr dt since yung du we're talking about naman yung difference in radius naman nila. And yung dy naman natin, we can replace it as t. Yun yung thickness ng oil dito. Okay? So ito naman is angular velocity, no? And then ito yung t is equals to y rin naman, no? Sige, let's substitute. So at 40 millimeters, mu times yung velocity gradient at 40 millimeter, ano yung itsura niya? Ito lang naman siya. So we just substitute lang naman yung angular velocity times yung respective radius niya at 40 millimeters. So yung thickness niya is still 1.5 millimeters. So magka-cancel out pa rin naman yan. Cancel seconds, cancel yung millimeter. That will be 7.032 Pascal or Newton meter squared. At 80, ganun rin. We're given na yung dynamic viscosity nito. We just simply multiply them and substitute and then we will receive the answer ng 14.06 Pascal. Yeah. Gonna be honest with you, ito dapat yung unang example ko ng viscometer. Mas madaling tignan kasi who cares about yung derivation na yan. Questions?
Sir, saan po na po grad na yun?
Saan napunta yung rad? Okay. Actually, di ko rin alam eh.
Dimensionless po ata, sir.
Ha?
Nung ginugel ko rin po, sir, parang sabi po, dimension.
Yes. Yes, technically it's
Dito
dimensionless.
makante.
Yes, it's technically dimensionless. So parang tinignan ko rin siya before parang, you know what? I'm not gonna question this na. Okay, kung ito yung sinolve niya, fine, sige. Sino nagsabing dimensionless? Angelo ulit?
Hindi ko po kasi no, sir.
So, ulitin mo yung sinabi
Sabi
mo?
daw, ano pa, sir?
Ulitin mo yung sinabi mo?
Sir, ginugel ko po, tapos sabi po, pag nagsasolve daw po, tapos natira yung red. Pwede na po cancel since parang indicator lang po na single po yung.
There we go. So, that's yung explanation natin for today. Paano nawala yung radiance. So, thank you, Angelo, for providing that information to the class. Okay? Palakpakan kay Angelo. Yay! Yes, Jerome. Ay, there we go. Akala ko mag-raise ka ng hand. So, technically, yun lang naman yung mga problem sets natin. And kung titignan nyo sa fluid properties, medyo madali siya. Wait, may nag-PM ba? Sorry, wait lang. Check ko lang ah. What's with class and Facebook, eh, no? Tingnan ko lang kung mayroon pa ako nakulang. Balik tayo dito. So, yeah, that's pretty much it. Um, Technically, I can end yung presentation na dito. Uh, Actually, I'm gonna end yung presentation na dito. So again, just to remind you, yung sasagutan nyo is this, 1.4, 1-11, 1-8. I think naisulat ko naman dun kung ano yung sasagutin nyo eh. Then yung next neto, so yan hindi, so sample ko yan. Pero you will have your own 2103, 2105E, and then, actually yun na yun. So, hindi mo na kayo binigyan ng gano'n kasi mas parang gusto kong padaanin ko muna sa inyo. Bakit? Paano siya sinusolve. Okay? Then, end slideshow. Stop recording.